Hello everyone. So here we shall solve the questions of polynomials test, which was held on 30th March. So in the first question, it has been told to find the degree of the polynomial. We have to find the degree of the polynomial having zeros as -3 and 4. So if the polynomial has two zeros, it means its degree should be 2. Its degree is 2. So the answer is option A. Since why the rule is that the number of zeros of the polynomial should be same as the degree of the polynomial. Degree of the polynomial. Then in the second question, it has been told that the quadratic polynomial, the sum of whose zeros is -5 and their product is 6 is. So as we know that if the zeros of any quadratic polynomial are alpha and beta, then that quadratic polynomial e of x can be written as x square minus of alpha plus beta into x plus alpha beta. So here the sum of the zeros. So if the zeros we are assuming that is alpha and beta, then the sum of the zeros, which is alpha plus beta, that is given as -5, and their product is 6. It means alpha into beta is 6. So therefore, the required quadratic polynomial can be written as x square minus of -5 into x plus 6. So which is same as x square plus 5x plus 6. Square plus 5x plus 6. It means option A is the correct answer. Then in the third one, it is told that the quadratic polynomial p of x with -24 and 4 as the product and one of its zeros respectively is. So therefore, the sum of the product of the zeros, which is alpha into beta, that is given as -24. If I assume that the zeros are alpha and beta, and then here it is told that 4 is one of the zeros. So let us assume that the value of beta is 4. So the value of beta is 4. So therefore 4 alpha, that is equal to -24. So therefore alpha will be equal to -6. Alpha will be equal to -6. Then so therefore the zeros are -6 and 4. So their sum of the zeros is -6 plus 4. -6 plus 4, which will be -2. So as we know that the quadratic polynomial p of x can be written as x square minus of alpha plus beta into x, where alpha plus beta is the sum of the zeros plus alpha beta. So that will be equal to x square minus of -24 sorry. The sum of the zeros is -2. So it is x square minus of -2 into x plus minus 24. So this will be x square plus 2x minus 24. Therefore, option B is the correct answer. Then in the fourth one, it's told that if 2 and alpha are zeros of 2x square minus 6x plus 4, then the value of alpha is. So here it is told that 2x square minus 6x plus 4. This is the given quadratic polynomial, a given quadratic polynomial, and then its zeros are 2 and alpha. So here we can see that the sum of the zeros, which is 2 plus alpha, that will be equal to minus b by a, which is, since why, if the quadratic polynomial is ax square plus bx plus c, then the sum of the zeros, which is alpha plus beta, that is given as minus b by a, and the product of the zeros, which is alpha into beta, that is given as c by a. So therefore, alpha plus beta, which is 2 plus alpha, that is equal to minus b. Here b is minus 6 and a is 2 and c is 4. So this is minus of minus 6 by 2, which is 6 by 2, that is equal to 3. And so therefore I can say alpha will be equal to 3 minus 2, that is equal to 1. So it means option C is the correct answer, since here the value of alpha has been asked. Then in the question number 5, it has been told that, no, sorry, this was the fifth one. This is the fifth one, which I have solved. Okay, the fourth one we shall solve now. Fourth one is the zeros of the quadratic polynomial, which is x square minus x square plus 99x plus 127 are. So its zeros we have to find out. So we have to find the sign of the zeros. So here the zeros will be x equal to, if we apply the quadratic formula, here as you can see that if we assume that the zeros are alpha and beta, then alpha plus beta is 99 and alpha beta is 127. So alpha into beta is greater than 0. It means their product is positive. It means alpha and beta should have the same sign. They should have the same sign. Here alpha plus beta, that will be equal to minus 99, since it is minus of b by a. So alpha and beta, they should have the same sign, since why alpha into beta is greater than 0. Now their sum is coming negative. So it means that both should have negative sign. So both of them should have negative sign. So it means alpha and beta both should be negative. So the zeros of this quadratic polynomial should be both negative. So option B is the correct answer. So fifth one we had previously solved. Then the sixth one, it has been told that the number of polynomials having zeros 1 and minus 2 is. So the number of polynomials having zeros 1 and minus 2 is. So we can take the polynomial p of x as x minus 1 and x plus 2. Then this will also have the zeros as 1 and minus 2 are its zeros. Now we can also take, let's say, q of x, which is x minus 1 into x plus 2, then into x minus 3, suppose. So in this way, except the zeros 1 and minus 2, we can have other zeros also. We can have other zeros also, excluding these 1 and minus 2. So hence, lots of other polynomials can be formed, which can have 1 and minus 2 as its zero. So there can be infinitely many polynomials. There can be infinitely many polynomials which can have which will have 1 and minus 2 as its zeros, which will have 1 and minus 2 as its zeros. So it means the answer will be obviously more than 3. So option D is the correct answer, which is more than 3. The answer actually it is infinite number of polynomials we can have, which will have 1 and minus 2 as its zeros. Then seventh one, the seventh one, it has been told if one root of the polynomial 5y square plus 13y plus m is the reciprocal of the other, then the value of m is. So here we can tell the roots are alpha and 1 by alpha. Since why here it is told one root of the polynomial is reciprocal of the other. So alpha into, so we can say that the sum of the roots alpha plus 1 by alpha, that should be equal to minus b by a, which is minus 13 by 5, and the product of the roots, which is alpha into 1 by alpha, that will be equal to c by a, which is m by 5. So therefore m by 5 will be equal to 1. Since alpha and alpha we can cancel out, so therefore the value of m will be 5. So m is 5, so option C is the correct answer. Then similarly, in question number 8, it has been told if the zeros of the quadratic polynomial, zeros of the quadratic polynomial x square plus a plus 1 into x plus b are 2 and minus 3, then a and b value will be how much? So these are its zeros. So therefore we can tell some of the, we have to find the values of a and b. So here sum of the zeros, which is 2 minus 3, that will be equal to minus b by a, which is minus of a plus 1 by 1. So I can say minus of a plus 1, that will be equal to minus 1. So a plus 1 will be equal to 1. So therefore a will be equal to 0. So the value of a is 0. And product of the zeros, which is 2 into minus 3, that is equal to c by a. Here c, which is the constant term, which is b. So that is b by 1. So therefore b will be equal to minus 6. So b is equal to minus 6 and a is 0. So option D is the correct answer. Then in the question number 9, it has been told if 1 0 of the quadratic polynomial f of x, 1 0 1 0 of the quadratic polynomial f of x, which is equal to 4x square minus 8kx minus 9, is negative of the other. So it means we can say that here the zeros are alpha and minus alpha, since 1 0 is negative of the other. So then find the value of k. So therefore we can say sum of the zeros which is sum of the zeros which will be equal to alpha plus of minus alpha, that is equal to minus b by a, which is minus of minus 8k by 4. So therefore alpha plus minus alpha, which will be 0, that is equal to 8k by 4, which is 2k. So k will be equal to 0. So 2k is 0, it means k should be 0. So the value of k is 0. So option D is the correct answer. Then in question number 10, it has been told that if one of the zeros of the quadratic uh, polynomial, which is a minus 1 x square plus ax plus 1 is minus 3. So here one of the zeros is minus 3, then the value of a is. Then the value of a we have to find out. So let's say the zeros are minus 3 and alpha. Since the other zero has not been told here. So suppose these two are its zeros, then we can tell sum of the zeros, which is minus 3 plus alpha, that will be equal to minus b by a. Here b is equal to a actually. Here is minus a by, and a is, which is the coefficient of x square, which is a minus 1. And the product of the zeros, which is minus 3 alpha, that will be equal to c by a. This c is the constant term, is 1 by coefficient of x square, which is a minus 1. So then the value of a you have to find. So from here we can see alpha, we can say that is equal to 1 by minus 3 into a minus 1. And this, or alpha, I can say that is equal to 1 by 3 into 1 minus a. So this value of alpha we can put in the equation, this equation 1 here. Then we will get the value of a. So which is minus 3 plus 1 by 3 into 1 minus a, that is equal to minus a by a minus 1. Which we can, now we can say that it is 1 by 3 into 1 minus a, and I can say plus a by a minus 1, that is equal to 3. Now this I can write, 1 by 3 into 1 minus a by 1 minus a equal to 3. Since a minus 1 can be also written as minus of 1 minus a. So therefore now we have to take the LCM. LCM of this will be 3 into 1 minus a, and here is it will be 1 minus of this will be 3a, that is equal to 3. Now we can cross multiply. 3 is 3 by 1, then we can cross multiply, then we will get 1 minus 3a, that is equal to 3 3 0 9, 9 into 1 minus a, which means it will be 1 minus 3a, that is equal to 9 minus 9a. So therefore I can say 9a minus 3a, which is 6a, that is equal to 8. 6a, that is equal to 8. So therefore a will be equal to 8 by 6, which is equal to, if we put 8 instead of 6, so a will be equal to 4 by 3. A will be equal to 4 by 3. So therefore option A is the correct answer. Then we will start with section B questions, which starts from question number 11, of 2 marks each. In question number 11, it has been told to find the value of t for which 1 0 of the, so find the value of t for which 1 0 of the polynomial 3x square minus 4x plus p is reciprocal of the other. So 1 0 is reciprocal of the other. So here, let's say the zeros we can take as alpha and 1 by alpha, since 1 0 is reciprocal of the other. So therefore now product of the zeros, which is alpha into 1 by alpha, that is equal to c by a. Here the constant term is p and the coefficient of x squared is 3. So p by 3. So p by 3 will be equal to 1. So therefore p will be equal to 3. So p equal to 3 is the answer. Then question number 12, it has been told find the zeros of the given quadratic polynomial, which is 6x square minus 13x plus 6, and then verify the relation in between the zeros and its coefficients. So here, let's say the zeros are alpha and beta. So let alpha and beta be the zeros. we have to find the zeros, so we can factorize it. So we know that 6 into 6, that is 36. 36 is equal to 4 into 9. 4 nines are 36, and 4 plus 9 will be equal to 13. So we can split this 13x into 4x and 9x. So then we will get x square minus 4x minus 9x plus 6. So then this we will get 2x we can take as common. So 2x into 3x minus 2 minus we can take 3 as common from these two, minus 3 into 3x minus 2. So then we will get 2x minus 3 into 3x minus 2. So hence, therefore, the zeros are, we will have to do 2x minus 3 equal to 0, then we will get x equal to 3 by 2. And if we take 3x minus 2 equal to 0, then we will get x equal to 2 by 3. So 2 by 3 and 3 by 2 are its two zeros. So therefore, the zeros are 3 by 2 and 2 by 3. So these are the required values of alpha and beta, which we have assumed that are the zeros of this quadratic polynomial. So we have to now verify the relation also in between the zeros and the coefficient. So as we know, sum of the zeros, which is equal to alpha plus beta, that should be equal to minus of b by a, which is the minus of coefficient of x divided by coefficient of x square. So now here, as you can see, alpha plus beta, that is equal to 3 by 2 plus 2 by 3. And that we will get it as the sum of 2 and 3 is 6. So 2, 3 is 6 is 9, 3 2 is 6, 3 is 4, so 13 by 6. So which is obviously equal to minus of b by a, which is minus of minus 13 by 6. So hence it is verified. This is the sum of the roots, that is sum of the zeros that is being verified. And then we have to check the product of the zeros also. So as we know, product of the zeros, which is alpha into beta, that should be equal to c by a. C is the constant term, by a is the coefficient of x square. So we have to check that if it is same as the constant term by the coefficient of x square or not. So here the product of the zeros, which is alpha into beta, that will be obviously 3 by 2 into 2 by 3, that is equal to 1. And which is obviously same as 6 by 6, since the constant term also is 6 and the coefficient of x square is also 6. So hence, this is also verified. So then in the question number 13, it has been told that if m and n are the zeros of the polynomial x square plus mx plus n, so its zeros are m and n. Then find the value of m minus n. M minus n value we have to find out. So as we know, sum of the zeros that is given as m plus n, that is equal to minus b by a, means minus of the coefficient of x, which is m by a. Here the coefficient of x which is 1. So here it has, so one of the equations is m plus n, that is equal to minus m, which is equation 1. And product of the zeros, that is equal to m into n, that is equal to c by a. C is n by coefficient of x square, that is also 1. So the second equation we get mn is equal to n. So this is equation 2. So now we have to solve and find out value of m and n. So here we can, if we solve it, if we solve the equation number 2, then we will get mn minus 1, that is equal to 0. So n into m minus 1, that is equal to 0. So here we can get n equal to 0 or m equal to 1. So the first case we can take case one, which is when if n is equal to 0, then we will have m will, if we put that in the equation 1, then we will get m is equal to minus m, but then 2m will be equal to 0, so then m also will be 0. So then we will have both roots are both the zeros of this polynomial are zeros only, then in this case, in case 1, m minus n value will become 0 minus 0, that is 0. So 0 is one of the answers. And then in case 2, which is m, if m equal to 1, then n obviously will not become 0. So if m is equal to 1, then m is equal to 1, then we will have 1 plus n, that is equal to minus 1. If we put that in the equation 1, so n will be equal to minus 2 in that case. So then in that case, m minus n value will be equal to 1 minus of minus 2, which is equal to 1 plus 2, which is equal to 3. So 3 is also one of the answers. Then question number 14, it has been told that find the value of, so but here if if you write only the answer 3, then also you will get the full marks here. If you don't include n equal to 0, here n equal to 0 also is one of the cases which we obtain here. But if we don't include and we can, if we cancel out this n, then also we will get only n is equal to 1, which is case 2. Then we will get the answer as 3 only. And then also we will get full marks. So then find the value of alpha power 4 beta power 3 and okay plus alpha power 3 beta power 4. This value of this we have to find out, where alpha and beta are the zeros of the quadratic polynomial f of x, which is x square minus 4x plus 3. So here actually we can solve it by two ways. We can exclusively find out the zeros alpha and beta, and then we can put that in the place of alpha and beta, and then we can find the value of that, or else we can find out the product and sum of the zeros, then we can put that here. Since why this value, let's call it as case, so this value we have to find out. So this from here we can take alpha power 3 into beta power 3 as common from these two terms, and then we can say alpha power 3 into beta power 3 into alpha plus beta. So here we can say this is alpha beta power 3 into alpha plus beta. So from here the sum of the zeros alpha plus beta, that is equal to minus b by a, which is minus coefficient of x, which is minus 4 by a, which is 1, which is equal to 4, and the product of the zeros, which is alpha beta, that is equal to 3. So then from here we will get 3 power 3 into 4, so that is 3 power 3, that is 27 into 4, which is the 28, 8, so 108. So 108 value we can get here, or we can exclusively find out the values of alpha and beta from here. If we factorize it, then we will get x squared minus 4x plus 3. Then we can say x squared minus x minus 3x minus 3. And then we can say that is x into x minus 1 minus 3 into x minus 1. X, sorry, plus it is minus 1. So then we will get x minus 1 into x minus 3. So obviously we can say that here the zeros are 1 and 3. Zeros are 1 and 3. And then therefore we can take alpha as 1 and beta as 3. So then therefore the value of the required constant, which is alpha beta whole power 3 into alpha plus beta. That value we have to find out. So that is 1 into 3 power 3 plus no into 1 plus 3. So that is obviously 3 power 3 into 4, which also will be equal to 108. So in this way also we can solve and find out the same answer. It is 108. Then 15th one, it is told that write a polynomial whose zeros are 2 plus root 3 and 2 minus root 3. 2 minus root 3, these two are its zeros. So here we can say that sum of the zeros that is 2 plus root 3 plus 2 minus root 3, which is given as root 3 will cancel, which is 4, and that will be equal to minus b by a, which is minus of coefficient of x by coefficient of x squared. So if the quadratic polynomial f of x, we can say that it is some constant k into, or you can say it is ax square plus bx plus c, then obviously this sum of the zeros is equal to minus b by a. So from here you can see b will be equal to minus 4a, minus 4a, and product of the zeros, it will be equal to 2 plus root 3 into 2 minus root 3, which is equal to 2 square minus root 3 whole square, since a plus b into a minus b is a square minus b square, which is 4 minus 3, that is equal to 1. And that is equal to c by a. So therefore we can say c is equal to a. So therefore the quadratic polynomial can be written as f of x, that is equal to ax square, then minus 4ax plus a. So from here we can take a as common, and then we can write a into x square minus 4x plus 1, or we can, instead of a, we can take this constant as k, and then we can say that the required quadratic polynomial is the required quadratic polynomial is uh, a into x square minus 4x plus 1. So this is the answer. Then in question number 16, it has been told that alpha and 1 by alpha are the zeros of the polynomial. Alpha and 1 by alpha are the zeros of the polynomial 4x square minus 2x plus k minus 4. Then find the value of k. K value we have to find out. So here you can say that the product of the zeros, is alpha into 1 by alpha, that is equal to c by a. C is the constant term, which is k minus 4, by a, which is 4. So from here you can see k minus 4 by 4, that is equal to 1. So then we can cross multiply. So k minus 4, that will be equal to 4. So therefore k will be equal to 8. So the value of k should be 8. Then in question number 17, it has been told that the sum and the product of the zeros of the polynomial are equal. So it means the quadratic polynomial, which is 4x square minus 27x plus 3k square. Now its zeros, I can say that is alpha and alpha, means the zeros are equal. Then the value of k we have to find out. So from here we can see that the sum of the zeros, which is alpha plus alpha, that is equal to minus b by a, which is minus of minus 27 by 4, which is equal to 27 by 4. So therefore 2 alpha, that is equal to 27 by 4. So alpha is equal to 27 by 8. So it means each of the zeros are 27 by 8. So then product of the zeros, which is alpha into alpha, that is equal to c by 8, which is 3k square by 4. 3k square by 4. So therefore alpha into alpha means 27 by 8 whole square. 27 by 8 into 27 by 8, that is equal to 3k square by 4. So therefore from here you can say k square will be equal to 27 by 8 into 27 by 8 into 4 by 3. Now 3 9s are 27 and 4 2s are 8. So from here we can see we will get k square will be equal to 9 7 63, 9 63, 9 18, 243, 243 by it is a 16. So this is 1 second. Minus 27 by 4. So product sum of the zeros is minus b by a. 27 by 8. So this is 27 by 8. Product of the zeros that is equal to b by a. 8, 3, 27. Okay, sorry. Here solution is wrong. Actually, here it has been told that sum and product of the zeros are equal. It means sum and product of the zeros are equal. This is wrong. This solution is wrong. Sorry. Solution is wrong. So here, let's say the product, uh, let's say the roots are alpha and beta. So here it is told sum of the zeros, which is alpha plus beta, that is same as the product of the zeros, which is alpha into beta. So alpha plus beta and alpha beta, they are same. Then k value we have to find out. Okay. So here alpha plus beta, which is the sum of the zeros, which is equal to minus b by a, which is minus of minus 27 by 4, and the product of the zeros with alpha beta, that is c by a, which is 3k square by 4. So therefore these two are equal, it has been told. So we can say 27 by 4, that will be equal to 3k square by 4. So from here 4 and 4 will get cancelled, and 3 9s are 27. So k square will be equal to 9. So k square is 9. So k will be equal to plus or minus root over 9, which is plus or minus 3. So these are the two values of k. So plus minus 3 is answer. Then this in the 18th one, it has been told that if alpha, beta are zeros of the quadratic polynomial p of x, which is equal to kx square plus 4x plus 4. So here the zeros are alpha and beta. Then find the values of k. Find the values of k says that alpha plus beta whole square minus of 2 alpha beta, that is equal to 24. Is equal to 24. Is equal to 24. Then here, so sum of the zeros, which is alpha plus beta, that is equal to minus b by a, which is equal to minus 4 by k. And the product of the zeros, which is alpha beta, that is equal to 4 by k, which is c by a. So then we can say that alpha plus beta whole square means minus 4 by k whole square minus of 2 into 4 by k, that is equal to 24. Then k value we have to find out. So here we can say that this will be 16 by k square minus 8 by k, that is equal to 24. So now we can take the LCM of k square, and k is obviously k square. So here it will be 16 and minus this will be 8k is equal to 24. So now we can cross multiply, then we will get 16 minus 8k, that is equal to 24k square. Now then we can write this as 24k square plus 8k minus 16, that is equal to 0. From here we can take 8 as common outside. Then we will get 8 into 3k square plus k minus 2, that is equal to 0. So therefore we can say this 3k square, 3 2s are 6. And so we can say 3k square plus 3k. So 8 I can cancel out. So 3k square plus 3k minus 2k minus 2, that is equal to 0. So then we can take 3k as common. So 3k into k plus 1 minus 2 into k plus 1, that is equal to 0. So from here we will get k plus 1 into 3k minus 2, that is equal to 0. So therefore the values of k will be minus 1 and 2 by 3. So these are the two values of k such that the required or the given condition will be satisfied. This given condition will be satisfied only for these two values of k, which are minus 1 and 2 by 3. So these are the answers. Okay, then in section C, which is 3 marks each, in question number 19, it has been told that if alpha, beta are the zeros of the polynomial 6y squared, which is, I can call it as p of y is 6y squared minus 7y plus 2. Here the zeros are alpha and beta. Find a quadratic polynomial whose zeros are alpha and 1 by beta, or 1 by alpha and 1 by beta. So here, also there are two ways to solve. Here we can explicitly find out the zeros alpha and beta, and then we can solve, or we can say that here the sum of the zeros, which is alpha plus beta, that is equal to minus b by a, which is minus of minus 7 by 6, which is 7 by 6, and product of the zeros, which is alpha into beta, that is equal to c by a, which is 2 by 6, which is 1 by 3, which is 1 by 3. And so we have to find out that quadratic polynomial. That quadratic polynomial we have to find out, which is, let's say we call it as g of x. So g of x will be equal to some, you can call it kx square plus uh, bx plus c, kx square plus bx plus c. So whose zeros are 1 by alpha and 1 by beta. So that quadratic polynomial g of x we have to find out. So here the sum of the zeros, which is equal to 1 by alpha plus 1 by beta, that we can write it as, can take the LCM, that is alpha beta, and here we'll get beta plus alpha, and that will be equal to minus b by a, which is minus b by k. So then we can say that alpha plus beta value, that is 7 by 6. So 7 by 6 by alpha beta, that is 1 by 3, that is equal to minus b by k. So from here we can say minus b by k value, that is 7 by 6 into 3 by 1, which is 3 to 6. So therefore minus b by k, that is equal to 7 by 2. So therefore you can say 7k, that is equal to minus 2b, or we can say b is equal to minus 7k by 2. B is equal to minus 7k by 2 is equal to minus 7k by 2. Okay, and then the product of the zeros. The product of the zeros, that will be equal to, product of the zeros, that will be equal to 1 by alpha into 1 by beta. So that is 1 by alpha beta, that is equal to 1 by uh, alpha beta, that is 1 by 3, that is equal to 3, and that is equal to c by k. So therefore c will be equal to 3k. So therefore the required quadratic polynomial g of x, that can be written as kx square, then minus 7k by 2 x plus 3k. Now we can take k by 2 as common here. K by 2 into, I can write 2x square minus 7x plus this, I can write 6k by 2 also. And this is 2k by 2 also. So k by 2, if I take it as common, this would be k by 2 into 2x square minus 7k plus 6. So we can write the equation as some constant k or k dash into 2k square 2x square minus 7x plus 6. This is the answer. Then here it is told in question number 20 that has been told that if the sum of the squares of the zeros of the quadratic polynomial f of x that is equal, which is x square minus 8x plus k, the sum of the squares of the zeros. So suppose its zeros are alpha and beta, then the sum of the squares of the zeros, sum of the squares of the zeros, which will be equal to obviously alpha square plus beta square, that is given as 40. Then find the value of k value I have to find out. So as we know, alpha square plus beta square, we can write it as alpha plus beta whole square minus 2 alpha beta also. So here the sum of the zeros, that is alpha plus beta, that will be minus b by a, which is minus of minus 8 by 1, and that is 8. And here the product of the zeros, which is alpha beta, that is equal to given as c by a, which is k by 1, which is equal to k. So therefore we can say this is given as 40. So 40 will be equal to alpha plus beta whole square. So 8 square minus 2k. So we can say 2k, that will be equal to 64 minus 40, which is equal to 24. So value of k will be equal to 12. So 12 is the answer. Then in the case study based questions, in question number 21, it has been told that two friends, Trisha and Rohan, during their summer vacations, went to Manali. They decided to go for trekking. While trekking, they observed that the trekking path in the shape of a parabola. The mathematical representation of the track is shown in the graph. Based on the above information, answer the following question. So the track or the shape of the path, it is a parabolic path. So its equation will be obviously, it will have a quadratic. So the equation of the path will be obviously a quadratic polynomial. Quadratic polynomial only it will come, and then it is shown that the graph is somewhat like this. It is intersecting the y-axis at the point 0, 30, and it is intersecting the x-axis at the points -4, 0 and at 7, 0. So obviously its zeros, obviously its zeros are -4 and 7. So hence in the question number 8 has been told the zeros of the polynomial whose graph is given are, that will be -4 and 7. So option B or option 2 is the correct answer. And in question number part B, it has been told what will be the expression of the given polynomial p of x. So therefore, the given polynomial p of x, we can write it as some constant k into x minus of -4, which is x plus 4 into x minus 7. Since why here -4 and 7 are its zeros. So then we can write it as some constant k. Here the constant k, obviously that should be any number which should be greater than 0. Since why here uh, the graph is, it is concave downwards, means it is a upward parabola. When it is a upward parabola, then in the equation the rule is the coefficient of x square should be greater than 0. So obviously this constant k should come greater than 0 only. So here we will have that one second just. So here, okay. So here the value of k should be more than 0 only. Since why when it is a upward uh, parabola, then the rule is the coefficient of x square should be greater than 0. So if we simplify it, then we will get that x square minus 7x plus 4x minus 4 into 7, that is 28. So then we will get that k into x square minus 3x minus 28. So here it is concave downward. So here the coefficient of x square should be less than 0 only. So here the, as I told, that was wrong. Actually, since the value of k should be less than 0 here, since the parabola is concave downwards. When the graph is concave downwards, then the coefficient of x square should be less than 0, and if it is concave upwards, then the coefficient of x square should be uh, greater than 0. So here k I can take it as -1 also, since by any negative number I can keep for k. So if we take k as -1, then we will get it as p of x is -1 into x square minus 3x minus 28. So then it will be minus x square plus 3x plus 28. So it means that option 4 is the correct answer. Then in part C, it has been told that the product of the zeros of the given polynomial is. So here the product, which is alpha into beta, so that is minus, it is c by a, which is c, which is the constant term, which is 28. What? Okay, then here, so it is 28 by -1, so which is equal to minus 28. So option 1 is the correct answer. Then in part D, it has been told that if f of x is equal to x square minus 13x plus 1, then f of 4 will be how much? So that will be 4 square minus 13 into 4 plus 1. So it will be 4 square is 16 plus 1 minus 13 4 is 52. So this will be 17 minus 52, which is, so 52 if we subtract 17, or I can tell 52 minus 20 plus 3, so that is minus 35. So it means D part, in part D, option number 2 is the correct answer. Then in question number 22, it has been told that in a pool at an aquarium, a dolphin jumps out of the water traveling at 20 centimeter per second. Its height above water level after t seconds. So that dolphin, the dolphin, it jumps out, and at time t, the height from the water level h, that is given as 20t minus 16t square, and it jumps out with a velocity speed that is 20 centimeter per second. So now then find the zeros of the polynomial p of t, that is 20t minus 16t squared. So if we have to equate it with 0, then only we can find out its 0. So if p of t is equal to 0, then we will have 20t minus 16t squared, that is equal to 0. Then from here, 4t I can take as common, and then we will have 4t into 5 minus 4t, that is equal to 0. Then we will have 4 I can cancel out, then we will get t equal to 0, or we can have 5 minus 4t equal to 0. It means we will get t here. In the second case, we will get 4t is equal to 5. So it means t will be equal to 5 by 4. So it means therefore the zeros of the polynomial, the zeros of the required polynomial p of t, the zeros of the polynomial p of t are 0 and 5 by 4. 0 and 5 by 4. So these two are the answers for the question number 1. So then in question number 2, it has been told that each of the following types of graph represents p of t. So here we can see that p of t, it is having, this is minus 16t square plus 20t, I can write it. So here obviously the coefficient of t square, that is negative. So obviously the graph will be concave downwards. Since why here the coefficient of t square is less than 0 here. And if it was more than 0, then only the graph would have been concave upwards. So here, if we take it as, so this will be minus 14, obviously 40 minus 5. So obviously the zeros are 0 and 5 by 4. So therefore, one of the zeros are zeros only. So it will pass to the origin. And so it will intersect at the point 0, 0 and at the points 5 by 4, 0. Since why 0 and 5 by 4 are its zeros. And since it is a height versus time graph, now time cannot be negative and height cannot be negative also. So the graph will be only the part of the graph which is in the first quadrant. Only that part of the graph which is in the first quadrant will be the answer. So h versus t graph, so it will intersect at 0 and 5 by 4. Zero and 5 by 4. Zero and 5 by 4. So in the second one, option A is the correct answer. And then in part 3A, it has been told that what would be the value of h at t equal to 2 by 3. What would be the value of h at t equal to 2 by 3? So h height is given as 20t minus 16t square. So the value of h at t equal to 2 by 3 we have to find out. So that will be equal to 20 into 2 by 3 minus 16 into 2 by 3 whole square. And since unit has not been told, so this will be, since the speed has been given in centimeter per second, so the height will come in centimeter only. So this will be 40 by 3 minus 16 into 4 by 9 centimeters. So this will be 40 by 3 minus 16 to 64 by 9 in centimeters. So this will be, if we take the LCM, 3, so the LCM is 9, so 3 3s are 9, 3 4s are 12, so 120 minus 64, so this is obviously 6, then 7, so 56 by 9. 56 by 9 centimeter, or we can write it as 6 9s are 54, so 6 2 by 9 centimeter, or we can write 6.2 recurring also, or you can write approximately 6.22 centimeter also. So hence 56 by 9 centimeter. So these 6 so by 9 or 6.22 centimeter, these are the answers for part 3A. And in the or part also, the or part has been told that 3 part B has been told that how much it, it, Christians has the dolphin covered before hitting the water level again. How much distance has the dolphin covered before hitting the water level again? So so it will hit the water level again at t equal to 5 by 4 seconds. Since why when we take the height equal to 0, when we take h of t equal to 0, then the values of t we will get 0 and 5 by 4. So it means the height was 0 at t equal to 0 also and at t equal to 5 by 4 also. So it means this 5 by 4 seconds is the required time of flight. So it means that it takes 5 by 4 seconds only to go up and then to come down to the same point. So, so hence how much it, distance has the dolphin covered before hitting the water level again? So here at so it means at 5 by 8 seconds, it will reach the highest point, which is half of the time of flight. So at t equal to 5 by 8 seconds, it reaches the maximum height. It reaches the maximum height. Therefore, how much distance has the dolphin covered before hitting the water level? So therefore, the required the distance covered, the distance covered by the dolphin, the distance covered by the dolphin, but before hitting the water level again, before hitting the water level again, that will be equal to the height, means that will be 2 times of the maximum height, which is, let's call it as capital H. So this capital H is same as the height at time t equal to 5 by 8 seconds. So that we have to, it's twice will be the answer. And in centimeter of obviously it will come. So here, therefore this height that will be equal to 20 into 5 by 8 minus 16 into 5 by 8 square, which will be equal to 4 to the 8, 4 5 the 20, that is 25 by 2, minus it is 16 into 25 by 64, 16 4 the 64. So this will be, the LCM is 4, 22 to the 4, 225, so 50 minus 25. So this is equal to equal to 25 by 4 centimeter. Yeah. 25 by 4 centimeter, or we can say speed into time, velocity into time, which is equal to the velocity with which it will come out, which is 20 centimeter per second into the time, that is 5 by 4 seconds. So this will be 5 4 5 20, that is 25 centimeter. 25 centimeter is the distance covered by the dolphin. Okay. So hope all of you have understood the solutions. Still any doubts if you have, please ask me. Means after the class. Thank you everyone. Bye.